recording now. All right, welcome back everyone to another Cybersecurity Pocket Edition workshop by the Q Project. My name's Solomon, and I'll be presenting a workshop on SQL injection today. So we're going to start off, before talking about SQL injection, just talking about what SQL is. It stands for Structured Query Language. And so really all you need to understand is that this behaves like a Microsoft Excel table, somewhat of the same way. So if you could just imagine how databases work, you have a bunch of these different tables or Excel sheets, and they can communicate back and forth. Some of them are holding user data like passwords and emails. Other ones could be holding orders and all that. And you use SQL as a language to manipulate them so you can connect them and all that. And so this would be like a super basic design 101 of an SQL database. You have 4 rows or 4 columns, 3 rows, and this would be a user table. So you have your usernames, emails, passwords on each row. And with an SQL query, which would be requesting some type of data from your database, one simple way of doing it would be select from user or select username. So this would be telling SQL to select just this column from, if this database or table is called users, you'd be saying select the usernames from this user table, where the email equals Joe Mo. It should be joemo@yahoo.com, and password equals password. So this query here is going to just select this first row for us. And when you're on login screens, that is what's happening in the background to access your data inside a database. And so if we're gonna manipulate this to do what we want, before we start, we should give a warning and say that everything we're showing is for educational purposes. And so if you are not doing this for educational purposes or trying to do it on a website that you don't have permission to do it for, you can probably get a felony or something like that. And so what is SQL injection? It's the attack on, it's poisoning a dynamic SQL statement. What that means is that the people that designed the database didn't design it, or they had poorly designed it to where there's dynamic statements, which means that, say on a login screen, your username and password would be able to change and be implemented into the query that we just showed back here. And so you can imagine that if there's an input field that someone random can access, and they can change what Joe Mo says and what password says and create another SQL query, then they're injecting SQL into somewhere they shouldn't be injecting it into. Basic examples of this are using SQL queries to comment out the rest of the query, or making it to where the statement is always true. And those two things would basically cause you to do whatever you want to do. And let me see. And another thing on this warning, I forgot to include it here, was that these resources are for education and they're used to help you protect yourself from these attacks. So if any of you are going out creating web pages or websites, you should understand that creating dynamics or SQL queries where people other than people that are authorized are able to put SQL statements into username login pages, you want to understand that that's not okay to do, because you can have data breaches. So this is the basic idea of what a SQL injection looks like. Say you're on a login screen for a web page, you have your username and your password, and when someone puts in WUM and their password here, this SQL query here is going to say select from WUM table. That would be the name of the database. where user equals that and password equals that. And that would be a typical SQL query, something that someone logging to a website would normally put. But that shows that this is a dynamic SQL query. So someone could go ahead and put this bottom one where it says 1 or 1 equals 1. It might look like gibberish, but what that's really doing is, if you look over here at the query, it's saying that you're selecting everything from that table where the username is equal to 1 or it's equal to 1 equals 1. The or statement is, or the or 1 equals 1 is what's causing an issue. It's basically saying that since 1 equals 1 always, unless we're on a different planet where the number 1 doesn't equal itself, this statement's always going to be true no matter what. And the same thing for the password here. So basically someone's injected SQL into this username and password field, and it's causing it to always return true, which is always going to return the entire database, which means that someone's going to just dump all the database information from one table just because of these two input fields. And so I think it's going to be useful to show how this works in actual SQL code. So I put some basic lines of SQL code to show how this is working in a real life setting. So we don't have to worry about the deleting database or clearing. That's just so I can clear it later on. But this right here, this would be a typical creation of an SQL table. If I run this, or as we should see first down in the left corner, I have a database section that's going to show my database tables. And if I use this here to create it, and I can explain what it's doing after I run it. Let's go ahead and try that one more time. There we go. So now if I refresh this database down in the bottom, you can see that there is a name here and it's equal to what I said create table is going to be equal to. This table is going to have 3 lines in it. It's going to have an ID, and this is going to be a unique ID for everyone. And then it's going to have an email and password. Right now, there's nothing showing up because we haven't inserted anything. And so these SQL statements down here are for inserting. It's saying that you want to insert into this table that we just created, and we want to insert emails and passwords. And I've just chosen random email and password to implement. If I use this or run these queries, and then I come back down here to the bottom left and I show the table, you can see that a basic table shows up. One that you might see if you're on like Excel or something. That's why I was relating it to Microsoft Excel. But you can see that this here is a simple table for a database. You have an ID, an email, and a password. If we scroll down to this section, we can see this is probably what a typical website login would look like. Say there is a username or email field and a password field, and somebody entered mmitchell@gmail.com and their password average. That would then be implemented into the SQL query. So select everything from this table where the email equals this email and the password equals this password, which is only going to include this line because those are the only ones that match what it's looking for. If I run this query, you can see that it only shows one line. So on a typical website, if someone was logging in and this query was asked, it's going to return this and it's going to show that that user had a correct login and it will log them in. But what we can do, like I was showing before, is change it up to put SQL inside of the username. So if we put a 1 tick or 1 equals 1, that is going to change this SQL query to say select everything from this previous table where email equals nothing, there's nothing inside the email, or 1 equals 1, and then these 2 dashes comment everything else out. Basically what this is going to do is it's only going to read this part, and it's going to say select everything from the table where email is blank or 1 is always true, which is always true. And that's going to go ahead and, or actually let me come over here. It's going to return the whole table. So if this SQL query was asked on a web page when someone put this in as their username and that is their password, it's going to return the whole table, and they could go ahead and download that somewhere and use it for malicious purposes or whatever they are trying to use it for. And so let's skip back out of VS Code and go on to the next thing. I'm now going to show outside of code how this would work on an actual website. And the way I'm going to show you guys how this works is by using SQL map. This here is just a Python file you can download on GitHub. Works on any operating system you want. And it is a open source pen testing tool that automates these SQL injections. Basically what this is going to do is, you can see right here, there's a legal disclaimer saying don't use it for illegal purposes. This is for penetration testing, which means that you have explicit permission to attack that website and find vulnerabilities in it. But this Python program automates that, so it injects all types of SQL statements and sees which ones work to figure out if there's vulnerabilities in the website that allows data to be breached. The way I'm going to do that is with this website here. This is a basic looking website, but if you look at the warning at the bottom, it talks about how this website is intentionally made to be attacked. So we're going to go ahead and attack this website. So let me first copy the URL. And for those that were here 2 weeks ago when I was doing the workshop on Google Dorking, we're now going to show how that would be used in an actual setting. So if I use the Google operator site and I put this website in with this, basically saying, look for all websites that include this URL with an add-on of PHP ID. You don't need to understand specifically what that means, but if we go to the first website, or not the first one, if we go to the second website, this here is a certain artist on this website that's intended to be attacked or hacked. We're going to go ahead and copy this URL. And instead of me having to specifically go in here and try and figure out what little like commas and dashes and stuff I need to put 1 equals 1, you don't have to do that. You can just use this Python program and it's going to go ahead and do that for you. So let me first open up my terminal. And inside terminal, I'm going to use this website link. And I'm going to run this SQL map Python program. I'm going to add a tac u. This is saying that you're going to put a URL. So let me fix the Python real quick. There we go. And so we're going to run the SQL map Python program with this URL. We're also going to add a dash capital D, or actually, no, not capital D, lowercase d, dbs. So what this is saying run this Python program on this specific web page and try and find all of the databases on this website. Something that would probably take you a few hours if you didn't know what you were doing. But if we run it on here, you can see right away there's 2 databases that show up, AccuArt and Information Scheme. These databases are similar to what I was showing you on Visual Studio Code. This right here, data.sqlite, is a database, and CSPE SQLI, which stands for Cybersecurity Pocket Edition, which you guys are attending right now. This is a table inside of the database. So right now we found two databases, but for us to get any use out of it, we need to find tables inside of the database. So we can go ahead and do that by removing this DBS and adding a D at QR. This is saying that we know the name of the database. So now that we know the name of the database, we want to search for tables inside of that database. So now this program has the functionality to attack the databases as well, or the tables inside of the database. If I run this, it's going to do the same thing, but now it's going to give me tables back. So what this is telling us is that this website here, this website has 8 tables in it. You can see that one of them is artists, which kind of shows up, and you can see that from here where there's artists with their random name. That's a lorem ipsum, that's why it's just random jumbled text. But you can see that this users table would probably be of use to us. So we can go ahead and we've attacked and we found all the tables in the website. Now we can attack the tables specifically and find what are inside those tables. So we're going to attack the users table, and we want to find the columns. And if you remember columns, like the example I was showing in Visual Studio Code, columns are like the email, username, password. So now we're going to find columns, and this program does that as well. You can see that it has 8 columns, and from these columns you would eventually guess to assume that uname and pass would be what you want to find. So now we can figure out what values are inside the username column and the password columns. If you've noticed, whenever I finish attacking a certain section going down the rabbit hole, I remove the lowercase and I add an uppercase tack. That's just the Python program's way of figuring out what it needs to do. So to refresh right now, we're running a Python program where we're giving it a URL, we're giving it a database, T table for users, and now we want to find, what was it? We're trying to find, we found the columns, so now we're going to add a C, and we're going to add the uname column, and now we're going to dump. Dump is a term for just getting all the information we can find. This table here seems to only have one value in it, test, or one row. We can go ahead and do the same thing for the password. And we can see password seems to be the same thing. So we've went down the rabbit hole. We used SQL injection from this Python program to find the database, then the table, then the columns, and then now we found the data we want, the username and password. Both the password and the username seem to be test. So if we go back to this website and we go to sign up, we can put test in and test. And if you log in, it logs you in. And so if this were a legit website, if you did that and you found a username and password, you would be logging into someone's actual account. Say it be a bank account, a social media account, something like that. So you can see it's very dangerous if the people designing the databases don't design it properly to prevent against these attacks. And with that, I'm going to give it over to Armand, where he's gonna talk more about, or I think he's gonna give an interactive example of how this works. So let me stop sharing. And now you can take it, Armand.
Yeah, thank you. Solomon. So right here, what I have is a home-built testing of the of SQL injection on a local website. Currently, it was working before. Of course, during production, it wouldn't work, but let's see how it works. And then I can also, what do you call? I can also demo it on the actual SQLite terminal window. So just give me a second. So right here. So I have this search for database kind of setup right here. So if I push, let's say just type 1, right? I press enter. I can see that this is a row in the database that I have. ID 1, name, product 1, and creator ID 1. So you can see there's lots of ones here. So I want to know, is it filtering my text via the ID product or the creator ID? So let's type product, enter. Oh, I see lots of these products. So if I put 4, then I'll probably just get this one right here. Let's check creator ID, because you can see here that there are only a couple of creator IDs. For example, right here, 2. Over here, there's creator ID 2. There's multiple ones for 2. And so if I click on 2, it only filters it either by ID or product. But since I could type product, I am able to get all of the items in here. So for example, let me show you. This is the console window. And so with this, I basically tested it out. So every SQL query it runs, it prints it out. Sometimes it doesn't work on the browser, but we'll see how that works. When to reset the database, I click reset. That's in case if I want to insert anything. And so it runs all these queries right here. So let's quickly go over these. So this one is drop table if exists user. So it'll destroy a table called users. And then the second one, on the first one, I guess you could say, it would create tables if not exists user. It would have 3 fields: an ID field, a name, an email, and a password. And it would insert these 3 values into it. And then over here, it would drop the table of product, which we have right here because there's a database and you're searching for these products. And then you have all these inserts into here. And that's what you have right here. You can also go here, if you go application, if you go to web SQL, or the name of the databases, you can here, you have all the different things here. You have the ID, you have the name, email, and then the password. Now let's get to injecting SQL into this. So here you have, let's go right here, Pro, where we put Pro. It added that percentage sign and then the 1 tick mark to fulfill the quotes around this. And so this is saying where select from product where the name has Pro somewhere in the actual name of the product. So if I misspell it, let's say POR, it wouldn't work. Let's say if I want duct works, or if I want DU is inside here, and so it works, not UD, enter. So let's say, or if I want to add some queries. So let's go right here. So I can mimic this. So I can actually enter in with user input. I could put that, and then that is for commenting out the rest. So right here we have this. I don't know why it's not working, but I have this exact same database right here. So if I run this command right here, select from product where that equals that, this is what I put in when I run a regular query right here. That's why I put in the actual program at where it would run. And you can see that it actually just runs all the, gives you all the products. So now let's run something like union. It would join two tables, select user, no, let's say all from all users, from select all from user. All right. And so let's run this query right here. We can see usually it would give you an error right here. Selects to the left and right of union do not have the same number of result columns. So you can see that the user either has a smaller number of columns than this, or a larger number of columns from this. So we can just set up, we know that there's 3 columns right here. So let's think of some regular column names that would be in a table of user. And I would like to open this to the public. So does anyone have any ideas? What are some common names you can put in a user table?
I guess a hint would be what we were going over before this when we were showing user tables.
Yeah. So what kind of columns? Okay, let's go for one column. Maybe name is one. What
Do email,
email, and then
password.
password. Yes, we all have this. You guys know this from here, from seeing this right here also. So that's just another thing. So if I enter here, yeah. Now if I copy this SQL statement, I enter in here, I see that it gave me all the products as well as all of these. I got Ben, I got Max, and I got Simon. I got their emails and I got their passwords through this right here. So this is the power of SQL queries. And so what you have to do to avoid this is basically filter out all the words and make sure that there's no words like union or select. But of course, you have to be very careful, because what if there's no space between here and you want to search up builders union like that, and that's part of your actual database. So you could say that, okay, if union is in there, then make sure that if there are spaces before and after the word union, then you can filter that out. You can say you can't run this search, or you can just take it out. Another way is when you actually run the SQL query, you can actually parse all this information and see, oh, is it accessing the user table, or is it accessing anything else? Then you can not provide that information to the front end service or send that information to the user. Another way is not to name your tables just simply user or users. You can name it something crazy like that. Of course, all of this stuff would be hashed your password especially should be hashed. I'm sure you heard of some passwords being leaked and everything, so you have to be careful who you give your passwords to because they might not do a secure hash. For example, MD5 is not secure. You can easily break it up. So, and plus the column names, you can make it something like this for password: email e at il. I'm not sure if you can do that, but you can do some random thing. But the problem is when you're testing it, it's kind of hard to debug because unless you're really good at naming stuff, perhaps you can have random characters right here, and then in the middle you put name, in the middle right here you put email, and in the middle here you put, what are you doing, password. You can do stuff like that. That's of course another way you can do it. But of course, you would need to reject all queries that have special characters like the percentage sign, especially this right here. These two dashes, that's the line comment for SQLite. So this is my part. Thank you, Solomon, for giving me access to share it to everyone.
All right. So I will share again, and then I'll do one more or go over one last bit before we end today's workshop. All right. So back to the slides. I'm going to give you guys this link here. Actually, I may need to. I'll send the link to you guys in a second when I get it. I can't copy from a PDF, but this here is a really cool website for going over just the basics of what an SQL injection does. So let me see, I should just be able to find it. If not, I can go like this. So here we go. So feel free. We won't go over this in this workshop. But this website is really cool because it just explains what an SQL injection is. So this will just reiterate what we were talking about today, because we went into the depths of kind of what this is and how it actually is used in like real world applications. But this will go over a quick understanding again. So yeah, let me send it to everyone. So you all can visit that link. And then before we end, I think Armand wants to share one last thing. So let me stop sharing. You can go ahead and take it again.
Of course. Yeah, I got it working. So basically, I have this right here. So let's start with product, right? We start with product, enter. We got all of these these regular products. Now if I do that, now if I do union, select what we did before, user, email, password, user, enter. Shoot. Okay, never mind. It was working right before. But
it's camera shy.
Yeah, exactly. So, but you guys saw it before, right?
Yeah, I saw it.
Okay, that's great.
So yeah, with that, that's the end of our workshop today. So if you guys enjoyed it, you guys go ahead and check out our YouTube channel for other videos. It should be posted on our Facebook classifieds if that's where you found this link from. And with that, I'm gonna stop this recording.